started now. Hi, everyone. Thanks for joining us today. My name is Elena Chia, and we also have Jim Vanderwall here from the Fraser Basin Council. The webinar we have today, Forecasting and Responding to Storm Surge in BC, is part of our webinar series on local governments preparing for sea level rise. In the next few months, we have two more webinars. One on assessing coastal risk in the Capital Regional District, and another on planning for a resilient waterfront at Qualicum Beach. So keep your eyes out for those. And these webinars are part of the BC Regional Adaptation Collaborative Program. So what the Fraser Basin Council is doing through BC RAC is supporting local governments and First Nations in preparing for climate change adaptation. And a part of the BC RAC program is our Retooling for Climate Change website. So if you're looking for resources in climate research, guides, case studies, or other tools to support adaptation planning, you can take a look at that site. And I just also want to note that this work is being supported by Natural Resources Canada's Adaptation Platform Program, as well as the BC Ministry of Environment. And just going over some webinar logistics. Right now your audio is muted, and we ask that you keep it muted to limit the background noise. If you have any questions throughout the presentation, you can type them into the question box on the side. We will have our Q&A session after the speaker's presentation, but feel free to type in questions as you think of them. Also, if you encounter any technical difficulties, you can also type that into the question box, or you can send an email to fraserbasin@gmail.com. So today we're really fortunate to have Scott Tinnis from the BC Storm Surge Forecasting Program. Scott Tinnis is originally from Victoria, and he did his undergraduate degree in physics at UVic. Afterwards, he graduated from UBC with a PhD in physical oceanography before starting a consulting career in numerical modeling, including 2 years at the Canadian Centre for Climate Modeling and Analysis. Now, he splits his time between the BC Storm Surge Program and Lorax Environmental in Vancouver. And today, for this webinar, Scott will be providing an overview of the BC Storm Surge Forecasting System, which has been providing stakeholders with warnings of extreme water level events. And the system also supports advanced planning through pre-season synopsis of climatological conditions and an extreme tide calendar for sensitive areas. So Scott's work is very valuable as BC's low-lying coastal communities are particularly vulnerable to storm surge from active Pacific storms, seasonal spring high tides, and atmospheric phenomena like El Nino. So at this point, I will pass it off to Scott. So we're just going to change our presenters.
All right, thank you very much, Elena. I hope that's coming up there. Good morning, everyone. I'm Scott Tinnis, the developer and operator of the BC Storm Surge Forecasting System. This is by no means a solo effort. It's been done in collaboration with Dr. Rick Thompson at the Institute of Ocean Sciences in Sydney, as well as a close partnership with the Climate Action Secretariat. I'd like to thank, in particular, Thomas White and Sarah O'Keefe at the CAS, as well as a long-time collaboration with Tina Neal, who I believe has gone on to a new portfolio, as well as Ben Kangaznimi, who was really there helping us spearhead the program when we started this about 9 years ago. So I've broken the webinar today into two parts. The first is an overview of what exactly is storm surge and why is it important to BC. And the second part is more a detailed look at the forecasting system that we've been developing And I'll do that in context with looking at what we're expecting for this year. And in particular, there's been a lot of talk about Godzilla-type El Niños and blobs of warm water off the west coast. And I want to try and tie that all together so that we have kind of a better understanding of really what's important when we're talking about storm surge and the potential for coastal flooding. So we'll start with a definition, two definitions actually. Storm surge, this is a sea level rise above normal, and I put expected here because expected is important, water level in response to what's happening in the atmosphere. And this comes in two parts. The main part is the wind, but another important part is the reduced atmospheric pressure that always accompanies low pressure storm systems. The second definition is total water level, and this is actually the more important of the two parameters, and this is simply the storm surge plus the tide. Just a quick look at this is a cartoon of what a typical low pressure system might look like approaching the west coast. So it's got several parts. First, the low pressure system itself, and the winds go cyclonically around it, so they go counterclockwise. They follow a storm track, so that low pressure system will track along the projected storm track to the coast. And in the northern hemisphere, if the winds are predominantly from, say, the south, they move to the surface transport, which is the upper layer of the ocean, will move to the right of the wind. So when a storm is approaching on the trajectory that I've shown here, the southerly winds will force the water onto the coast. So we get a two-pronged effect from the storm. The next slide, we'll take a cross-section just looking at the effect of atmospheric pressure. So on top, I've just depicted the storm with a cloud and shown a graphic of what the pressure is doing underneath that system. So average sea level pressure is just over 1,013 millibars. We may see 980 millibars as a typical low for a strong low pressure system. So the difference there is just over 33 millibars. And underneath that low, there actually is a sea surface response. The low pressure actually draws water up, and we see a rise in sea level below that low pressure system of approximately 1 centimeter per millibar. Per millibar difference between the low and the global average. So in this case, for a 980 millibar low, we would see something like 35 centimeters of rise. And that lump of water will travel underneath the low pressure system and travel up onto the coast. To put in context our situation versus large storm systems and notable storm surges from the past, I've picked a couple of well-known hurricanes, and as is usual with these things, when you create your slides for a presentation, they become immediately obsolete. I think I put this together on Friday, just before Hurricane Patricia hit Mexico. So at the time, Typhoon Haiyan was one of the largest. Hurricane Katrina is the one that I sort of pull out first, usually when I'm talking about storm surge, simply because not only was it was a Category 5 hurricane that was reduced to a Category 3 when it hit the coast of Louisiana, but it brought a massive storm surge of nearly 30 feet and did incredible damage to New Orleans, in part because, of course, New Orleans is very low and it's protected by dikes that weren't sufficient to handle the storm surge. Typhoon Haiyan was a couple of years ago. By all accounts, was a much larger system. The central pressure there was 895 millibars, so anything below 900 is amazing. Um, and you can see that the low pressure system is responsible for, or the low pressure itself is responsible for about a meter of surge. The total surge is about 6 meters. You can see the wind has an incredible influence on tropical storm systems and their surges. So the bottom one, and I don't mean to diminish storm systems and storm surges compared to tropical storms, but it gives you a bit of perspective. One of the strongest storms, most damaging storms we've had recently was in February of 2006. And this is when parts of Boundary Bay were inundated with both by storm surge and very strong winds because it was a very intense southerly wind flow. So the wind was blowing water directly onto the communities there. And as measured at Point Atkinson, the storm surge total was 91 centimeters. So that was both the effect of the low pressure and the wind. Now, it was about 980 millibars low, so we could see that there's about 35, 40 centimeters of that 91 is responsible or was caused by the low pressure. So a rule of thumb is 50-50 for our area of the world for our extratropical storms. We have wind gusts from 80 to 100 kilometers an hour, but our sustained winds are nothing like hurricane force winds. So about half and half, and that's a good rule of thumb for extratropical storms. Okay, this is arguably the most important slide that I'm going to present today. And what I'm showing you here is for the last 52 years, if you take the largest single surge event in a given year and plot it, we can see not only the range of storm systems, but if we plot it correctly, we can get an idea of what their expected return period is. And so if we look at the very bottom here, I hope my cursor is showing up, our minimum expected surge in any given year is approximately 45 centimeters. The maximum over this 52-year period of record is just over a meter. So there's our range, approximately half a meter to just over a meter. It's not a very broad range, but there's a broad range of implications within that. So, for example, the peak storm that we saw, ironically, was during a La Nina. We always think of El Nino as being the thing that brings coastal flooding, but in fact, this was a year after the major El Nino in 1997. And this came during probably one of the wettest periods on the West Coast for a very long time. There was a series of storm after storm, and I think the final snowpack up at Mount Washington was close to 8 meters in April of 1999. Now, I've taken some pains to plot the El Nino years since 1972, and I've just put a ring of red around them. Ironically, again, 1997, the tide gauge at Point Atkinson was not working. So we don't have a direct measurement. What I did was I went back and looked at some close tide gauges and did a correlation between the two, and I reconstructed what I believe the 1997 record looked like at Point Atkinson. And it looks like there was an event in the mid-80s. One last thing to note, last year we had a storm on December 9th, December 9th, 10th, and 12th. And during that series of 3 storms, we had an event that was 81 centimeters. Now that didn't occur at a particularly high tide, so the damage was kind of, was minimal, but 80 centimeters is kind of the break that's the starting of the large storms. So anything, if you're in a year and you don't get a storm of up to 80 centimeters, that brings an 80 centimeter surge, then that's considered a fairly benign year. So once we start getting above 80, we've got this range from 80 centimeters to a meter that really defines our large damaging storms. Now, the focus today is on operational forecasting. So we're looking more at weather than climate. But I just want to bring up one point, and this is from the IPCC AR5 report in 2013 on sea level rise projection. There's a range of scenarios here, but basically they're all showing that by 2050, there's a reasonable expectation that we could see a 20 centimeter rise in global sea level. That's going to affect different areas differently depending on their coastal structure. Even around BC, there are areas, there's great differences between what may happen in Tofino, say, versus what may happen near Richmond, because there may be coastal rise due to tectonics in Tofino, and there may be sinking of the Fraser River Delta near Richmond. So relative sea level rise is another question. But global sea level rise is expected reasonably to be about 20 centimeters by 2050. So if I go back here, I just want to emphasize the difference between what we think of as a strong storm and a megastorm is 20 centimeters. And to put that into perspective of return period, the return period right now for an 80 centimeter is approximately 3 to 5 years. A 1 meter event is 50 years, 1 in 50, 1 in 60 years. So that 20 centimeter rise in sea level is all of a sudden going to bring the 1 in 50 year event every 3 to 5 years. So that's just some perspective on the kind of thing we're looking at in terms of surge with the respect to sea level rise in the near future. So I've been speaking about surge, but I need to talk a little bit about tides. Now, this is a tidal record between October and April. The top one is Point Atkinson, the bottom one is Victoria. And of course, the main thing I want to show is the variability in tides. First of all, looking at the range from the lowest low to the highest high in any given short period is 5 meters. So we've got a 5 meter tidal range. And you contrast that with the storm surge, which is approximately a meter. So you can see that the storm surge relative to the daily variations we see in the tide is quite small. So that works in our favor. We're already used to large variations in tides. Victoria has actually quite a shorter tidal range. And the reason I want to bring this up is to kind of bring to the forefront that the tidal variations, even given small geographic separations, can be quite large on the West Coast. And so when we're looking at specific areas with respect to storm surge and total water level, which is the sum of the tides and the surge, we really have to know our areas very well. So it's very geographically specific. This is a very similar return period plot to the one I showed for storm surge, but this is for total water level. And so the idea again here is you take the highest total water level that is measured in any given year and you plot it for the 52 years on this semi-log plot. And you can use it to tell you something about the expected return period for a given total water level. Now, last year we reached just over 5.4 meters in December during that large storm. In February of 2006, the Boundary Bay storm, we reached just over 5 meters, 5.51, and the highest recorded for certain December 16th, 1982. That is our period of record peak at 5.61 meters. When I reconstructed the 1997 record at Point Atkinson, I also got another 5.6 meters on December 16th, 1997 as well. So December 16th seems to be a magic date. So again, this gives you an idea of what the range of peak water levels we would expect to see at Point Atkinson in any given year. Some years we get very little surge or no surge at all when the tides are at their highest, and so we sit right around 5 meters. And you can see that it's actually a fairly small range. It's only 61 centimeters between the lowest expected total water level and the highest. So I plotted out just some of the recently affected areas, this would be the last 5 years or so. Um, and you can see that there's large concern in areas where there's large populations, particularly in Boundary Bay, where there's susceptibility to run up by winds, strong waves, and again, it depends somewhat on how the storm actually hits and where the winds come from. But it's not limited to this area. Richmond and Vancouver, English Bay are also susceptible to coastal erosion and flooding. We get calls from the Sunshine Coast. They have lots of low-lying areas, and sometimes, as I mentioned, things can be geographically close, but their particular situations lead them to have different concerns and different levels of risk during very similar wind events. Powell River, I know, has lots of low-lying infrastructure and communities. And last year, in particular, looking at Courtenay and Comox and Port Alberni, there were issues with not only storm surge, but heavy rains associated with those storms. And the problem there was a lot of precipitation. There was 1 in 50, 1 in 100, 1 in 200 year river flow events from this precipitation. At the same time, they were getting very high tides plus surge at the mouths of the estuaries. And even though some of these rivers were dammed, they were unable to control the water flow because the reservoirs were full. And so what happened was there was a lot of flooding in the communities that were along the estuaries. And so I think last year we had 5 or 6 days in a row we were on emergency management calls, and there was a lot of concern from communities saying, are we going to see another surge? Are we going to see another high tide? And because we're not seeing any recession in the river flow. That also happened several years ago down in Cowichan Bay. And Victoria also has a lot of low-lying areas that are susceptible to winds and wave run-up during periods of storm surge and high tide. A couple of pictures. This one was given to me when I visited Powell River a few years ago, and it just shows the kind of typical inundation we see all around the Strait of Georgia and Juan de Fuca Strait. Lots of logs being washed up on the shore, lots of flooding. It's usually parks, low-lying roads. This one occurred with a surge of 75 centimeters, so just below we consider very large. But it also happened at peak tide. So the total water level at Point Atkinson was just under what I kind of consider a magic number of 5.4 meters. Again, last year, not last year, this is December 17th, 2012. This is a picture of the Stanley Park seawall on English Bay. This is a very interesting storm because we were tracking this with Environment Canada right down to the last minute. It brought with it a maximum surge of about 70 centimeters, and the weather models could not converge. They could not agree on when and where the storm was going to hit until 24 hours before the storm. So we were literally, on the phone the night before trying to figure out the timing of this storm. It actually hit 3 hours before high tide, and there was a great relief when that forecast hit, because had it hit 3 hours later, it would have hit at peak tide, and we would have had a 5.7-meter event at Point Atkinson, which is far and above the period of record that we have. As you can see, those 3 hours dropped the storm surge from 70 centimeters to about half of that. What was quite funny is that we all relaxed, and then the storm brought with it strong westerlies in its wake, and caught us, kind of blindsided everybody, and did a lot of very localized damage to the seawall, to Kitts Pool, to Ambleside Park, and it was just simply that exposure to the winds. So that ends the first part of the discussion, which is just an overview of storm surge. And I want to just go through the storm surge forecast program and try to put it into context for what we expect this year. So as I mentioned, this is Climate Action Secretariat funded program as of 2011 to 2015. So the funding ends this year, and our this is to provide scientific advice and particularly operational forecast capability for storm surge. This comes in two parts. We create what we call a preseason storm surge almanac, and that gives not only a short-term climate outlook. We look at factors such as El Nino and their expected effects on surge and storminess. But we also produce an extreme tide calendar, which is a nice encapsulation of when we expect to be most vulnerable with respect to what are called king tides in the wintertime. And then from October 15th onwards until we're no longer needed, we do daily 6-day storm surge forecasts using a numerical ocean model. And from those, from the results of the model, we produce bulletins for Victoria, for Vancouver, and for Powell River, which are updated hourly. So we check the water level gauges hourly, and we update our forecasts and make corrections as required. So the Storm Surge Almanac, it can be, it's published usually around September 30th, or the first week of October every year before the onset of daily forecasting. And we try to look at the relevant climate indices, in particular El Nino, the El Nino Southern Oscillation Index, and what's known as the Pacific Decadal Oscillation, which is just simply a look at the dominant mode of variability of sea surface temperature. And it's had past correlation with storminess. So, and the Pacific Decadal Oscillation sometimes can work in concert with El Nino. So we like to look at both of those and sort of let them guide us as to what the expectations for storminess are in a given year. And as I mentioned, we do an extreme tide calendar, and we do that for Victoria and for Vancouver, and that covers most of the Strait of Georgia as well. So this is a couple of time series just looking at these two climate indices. So on top is the Pacific Decadal Oscillation. Essentially, when it's positive or red, then the sea surface off the west coast is warm. And when it's blue, you can expect conditions to be cooler than normal. And one of the interesting things is that it's highly variable, it's very episodic, but it seems to go in periods where there are several decades at a time where it's predominantly cooler off the coast or predominantly warmer. And people like to point to the late 1970s as a regime shift between colder and generally warmer conditions. there is a loose correlation between the PDO and El Nino, and so the El Nino Southern Oscillation Index is shown below. I've tried to stretch the axes so that they line up. You can see there's kind of a broad correlation for what's predominantly warm. There may be more propensity for El Nino. It's not always true. Sometimes they're out of phase. When they're in phase, they may work together to enhance whatever effect El Nino or positive PDO brings. And it's up for debate what El Nino actually brings to us, but in general, we were on our toes when we're monitoring for generally more stormy conditions, especially if the storm track lies right over top of us. El Nino moves the storm track north and south, and sometimes bringing more storms than normal to California. But should it shift north, we could expect warm and wet conditions and more storms. And we've seen, at least in the case of 1982, El Nino brought the period of record largest total water levels at Point Atkinson. So we always want to be wary of that. I've tacked on our present PDO, which is strongly positive now. We seem to have switched out from a cool phase in over the last 10 years or so. We're now going into possibly a temporary warm phase, and we're expecting a very strong El Nino event this year. And I have, I think on the next slide, a view of the most recent sea surface altimeter satellite shots of the ocean. And in particular, you can see the effect of El Nino in the eastern Pacific. And what this is, you take away the effect of tides and you take away the effect of weather systems on the surface of the ocean, and what you're left with is the signature of the broader climate effects. And so we see this very, see if I can get my cursor again. There's a broad area of very elevated water that's traveling from the west side of the Pacific Basin to the east side, and it's bringing with it warm water. And if we look at 1997, this is the same sort of altimetry shot. We can see exactly the same signature, a broad expanse of water that's elevated and warm. And in 1997, that's tended to spread all around the North Pacific. So we're keeping an eye on what El Nino is doing. The expectations are, right now, the only thing we can expect is that it will look similar. So that's why we're also being very vigilant in storm surge monitoring. I'm just bringing up the tides again because, again, this is a fairly complicated picture. And what we've tried to do is to distill the tidal events into something that's more useful. And so from these time series, we've generated what we call the peak tidal calendars. And you can think of these as essentially the periods of king tides. And this is for Point Atkinson. Whenever the peak tide in a given day is within 40 centimeters of the largest expected tide in a year, we give it a yellow advisory level. And so we see that the yellow advisory levels don't really start until the end of November. That's not to say that we couldn't get a strong storm in early November that would bring peak water levels into a cautionary zone as well. But this is just solely looking at the tides. It really gives us an idea when we need to be extra vigilant. Moving into December, we see that the peak period is going to be, there's a small peak period in the middle of December, but we're looking more after Boxing Day, getting into a large period when tides are going to be very close to their annual maximum. And again, we see the same sort of thing in January, and then it begins to diminish into February. So We need to be vigilant anytime during these 4 months in particular, but when we start getting into periods where we get into a yellow or red cautionary advisory level, we are extra vigilant, and that's where the 6-day forecasts actually help, because then we can look 6 days into the future and say, is there any storm activity? Do we need to start looking very, very closely? Victoria, as I mentioned, has a slightly different tidal signature, but essentially the same picture. We see some advisory levels in the red at the end of November, but more towards the end of December is when we get our peak period. Broad swaths of yellow through December and January and early February as well. So for daily forecasting, a few years ago, we put together a web portal, which is just a place that we were putting everything, not only the daily forecasts, but archiving of previous almanacs, any reports that we generate for storm surge associated literature. But primarily on the front page, what you'll see is a map and the advisory level for the 3 areas that we are covering with bulletins. These advisory areas, these areas will change color depending on the advisory level. So green will go to yellow or red depending on what the forecast is showing us. And if you click on any one of those, it'll take you directly to the bulletin for the relevant area. And this is what the bulletin looks like. This is, as I say, updated hourly, and it's in 2 parts, but they essentially say the same thing. The calendar up top just gives you the peak water level, and it also gives you the time of day. And should this peak water level change from green to yellow or red, the color in this table will also change. And then you can look down below and you can see, you can get a more general sense of what's happening with the sea surface height. This includes the measurements from the tide gauge or the water level gauge in black. Red is the forecasted total water level, and you can see bits of blue peeking out, and that's the predicted astronomical tide. And a few years ago, it was requested that we break out the anomaly from the predicted tide. So what the model is showing as the predicted total water level is subtracted from the predicted tide and then shown on an enhanced graph down below. And that's so people can get a better sense of timing when the peak water level is going to happen, in case they apply it differently to their area of concern. One of my favorite parts of the web portal is the sea surface animation for the Northeast Pacific. And so this map over here, so you can see Alaska and the Aleutian Islands, the Haida Gwaii, Vancouver Island, and it goes all the way down to California. If the sea surface were calm, then this whole thing would just be blue. It would be sea surface height of 0. But when there's atmospheric disturbance, low pressure, or high winds, then we start moving into the warm colors. And this was for 2011. And it was, again, a very strong storm, this time in November. And let's see, I'll just play this a couple of times through so you can get a sense of the activity. You can see storm systems developing that show up as bullseyes. And as you can see, the sea level on the coast changes from green to red as they approach. And so this is another tool that you can use on the web portal to get a sense of what's happening and what could be happening in the future. Okay, if you're new to this system and you're asking yourself, how do I use the system? There's a couple of different ways to access the information. Surge BC is on Twitter, and I'll probably post maybe a dozen advisories a year, and and that's just to point people towards the web portal and to advise either if there's a particularly strong event coming, or if there's a problem with the system. If there's a power outage, if the tide gauges are out and they're not reporting, I'll report that as well on Twitter. And I usually refer the messages to the hashtag BC Storm as well. Again, I just described the Storm Surge BC portal. You've got the advisory level map that will tell you just about instantly all you need to know about the upcoming 6 days. And if you need to get in contact with me, my contact information is on the web portal. You can contact me through email, or you can phone me directly. Quick summary then for what we expect this year. We've got a very strong El Nino, which, as we've seen in the past, has been associated with high total water levels. We have a positive PDO, what people have been calling in the media the blob of warm water. Don't know how the two are going to interact. So again, it's coming down to we need to be very vigilant in day-to-day monitoring once the storm system, or once the storm season starts in earnest. King tides, those are easy to predict, and for the lower mainland and Strait of Georgia, we're looking at mid to late December and mid-January for peak tidal season. For Victoria, that's slightly different, but we're also seeing late December as our key king tide period. And I'm going to wind it up here. I just want to note that, as I mentioned in the first slide, I think 2015-16 is our last season under our current funding cycle, and we don't currently have a plan in place to continue. So if you're using the system or are interested in using the system, any feedback, any messages that you can send to me, I will tabulate, and we're building a business case to continue funding for the program. But as it sits right now, this will be our last season. I would like to acknowledge first the Climate Action Secretariat for their long-standing support and funding, Fisheries Oceans Canada, various other government agencies who provide us data, and I'd also like to thank Elena and Jim at the Fraser Basin Council for supporting today's webinar. Thank you very much.
Thank you so much, Scott, for to answer. All right, well, thank you for answering our poll, and you can see the results on your screen. It seems like there are about 29% of the audience have used the storm surge forecast, and many, 53%, are also looking into using it for this season. So we have our first question up from Sarah. What do you mean funding will run out? The program could be canned.
Well, we started 9 years ago with an idea, which was a bit of a spin-off idea, which got the attention of BC Ministry of Environment at the time. And so they provided some startup funding for us to branch out and just look specifically at storm surge forecasting. And we've been doing bridging funding up until 2011, when the Climate Action Secretariat stepped forward and said, you know what, we'd really like to fund this. Let's do this for a big stretch of time. So they actually gave us 5 years of funding, which was unheard of at the time and very welcome. But as we get to the end of this part of the mandate, I think the predominant feeling is that the CAS doesn't necessarily feel like they want to be in the business of doing the storm surge forecasting. And so we're looking at kind of a different umbrella to run it with. And whether that's with another government agency or whether it's with a third party, which gets funding from a collaboration from other people, I can't even envision how it's going to work right now. But our funding does end as of March 2016. And so unless we're able to find some bridging funding after this fiscal year, then the program probably won't be running next year. I would say definitely won't be running next year.
Okay, thanks, Scott. So our next question from Max. On the topic of sea level rise, is there any work being undertaken in BC looking at localized sea level rise? We are observing global sea level rises, but I'm wondering if it has been noticed along our coast.
Yes. Now, I guess there's two parts to that. Looking at relative sea level rise in different areas, I think the BC Ministry of Environment has an excellent report. And unfortunately, I don't know the name of it off the top of my head, but you can search, I think you can just search BC sea level rise, and on the first page of hits, you'll see there's a report that you can get from the BC government website, and it covers some of the things that I mentioned. It covers them in great detail. As for the application of sea level rise in the future to localized relative sea level rise, I think one of your presentations coming up is going to be on the CRD and how it specifically is looking at adaptation to sea level rise. So I think it's now being done in small chunks. So different areas are looking at it. So I don't know that the BC government is doing it as a whole. But certainly looking at what's been seen to date from the water level gauges, and now they're tracking GPS. They have GPS sites. I know that there is a report on the BC government website that's easily found.
Thank you. And I can answer the next question from Sean. So our presentation will be put up on Fraser Basin Council's retooling website, and the FBC also has a YouTube channel where the webinar will be posted as well. And then the next question from Mike, do you do storm surge forecasting for the west coast of Vancouver Island?
We have the capability of doing it. In other words, the model covers that area, and there is a tide gauge at Fino that we can use for our real-time corrections. All of that's essential. The only thing that's stopping us from doing it is, A, I haven't programmed that into the system yet, and B, I don't know if I'll be able to access the gauge in real time. So it exists, and it's part of the tsunami warning system. So I know that I can tie into it. It's just a matter of liaising with the hydrographic service and them being able to make those measurements available to me. And so we are looking at, because we had such a stormy year and a broad spectrum of areas that we hadn't realized before were in need of this of storm surge forecasting. I started to look at the viability of putting more stations in, and I think we could possibly go right up into Hecate Strait as well. So the answer is yes, we can do it, and I am looking into it this year.
Oh, sounds great. And Jennifer has a question. How can we support you to get funding for the program? Is there anyone we can write to in support of the storm surge forecasting program?
Well, that's a good question. Um, Probably the easiest thing is to maybe just send me an email and list, just in a couple of paragraphs or a paragraph, just say that you support the program or you would like to support the program, and this is why. And for each letter we get, I'll be compiling them and working with the CAS to put together a business case that we can then brainstorm some ideas on how funding and organizational structure will look in the future. But so probably if you can send it to me, then I can make sure that the CAS also gets a compiled copy of everything. That's the best I can think of right now.
Thank you. And Sean has another question. For people who don't use Twitter, can alerts be sent by email or text message?
Um, yes, I hadn't considered it before, but yes, I could put together an email list of people if they want to send an email to, is it surgebc@shaw.ca. I can put together an email list and just simply CC any messages through that. Also, if you are on the EMBC uh, email list, then they will, anytime something to do with storm surge is sent to them, they will kind of compile it and send it off through their channels as well.
Okay, thank you, Scott. So we have Matt McDonald who would like to make a comment verbally. So I'll have Jim open up the audio for Matt. Matt, are you
Yes,
there?
yes, thank you. Hi, Scott. Great presentation and great summary.
Oh,
And it's
thanks,
good
Matt.
to rejig our memories here heading into King Tide season. I'd just like to, I guess, comment on the previous question regarding emails. Obviously, Scott, as you know, in the past, we've collaborated with you in Environment Canada to issue early notifications, and that's something we'll continue here as we enter the storm surge season into December and January. So typically, Environment Canada, Scott Tinnis, and the River Forecast Center collaborate together. And whenever we see, a risk of storm surge impacting the coast, then we'll send out an early notification to emergency management officials. And we have quite an extensive distribution list of about 1,400 emergency managers across the province. So leading into the fall, you can keep your eyes open for emails from Environment Canada, and of course with ongoing collaboration with Scott and the rest of the crew.
That's probably the better way to go than my putting together a personal email list here. I think definitely look into getting on the EMBC distribution list.
Yeah, so if anyone's on the call today who would like to be added to that list, I guess they feel free to contact myself, Matt McDonald, at Environment Canada, and you can get my contact information through Ileana or Scott.
Great, thank you very much, Matt. Are there any more questions from our audience? Maybe give a few moments for people to reflect on that. And as they're thinking, I can launch our last poll over here about which adaptation topic are you most interested in learning more about? All right. Well, thank you for your input. Looks like there's a lot of interest in coastal management. Makes sense from this webinar, and emergency preparedness, and also looking at infrastructure adaptation. Thank you for participating. And we have another question from Christine. Will you be making the contact information available that is currently being shared?
Sorry, which contact information is that?
I wonder, Christine, if you could type again and clarify that. In terms of contact information from the Fraser Basin Council, you should be seeing on your screen now. For myself and Jim, if you have any questions or follow-up from the webinar, you can contact us at those phone numbers and email. So I'm not hearing back from Christine. If there are no other questions from the audience, I'll just close the webinar now. Scott, thank you so much for taking the time to be with us and present on the work that you're doing. And it seems from the number of people attending and all the questions that there's a lot of interest and value in what you're doing. So thank you so much for being with us today.
You're very welcome. It was a pleasure.
And also thank you everyone for taking the time out of your workday to listen to our webinar. As I mentioned, if you have any questions or comments, feel free to follow up with either me or Jim, and we will have this webinar posted on our retooling website and on our YouTube channel within the following week. Thank you. Have a good day.